This is just a simple primer on RegEx. I'll try to keep it down to 10 minutes. I work with Gabe at Lifelink. Okay. Okay, so what is RegEx? People call it different things. It means regular expressions. Sometimes people call it RegExp with the P at the end. I think most commonly people call it RegEx. Sometimes it's RE. And sometimes people call it ASCII puke for a very good reason, because sometimes that's what it looks like. RegEx is just a string that we use to search for or match on other strings. It consists of the regular characters that you're going to match on, also character classes that sort of define a range or a set of characters. And there are these metacharacters that can further define the search pattern, like in terms of repetition and stuff like that. And parentheses for grouping and capturing. I'm sure most of you have probably used RegEx already, so I'll try to breeze through this. What is RegEx? Well, it's anything that defines a regular language. This is Chomsky's language hierarchy. I don't really know what it means, but just know that regular language is the most confined part of his language hierarchy. Why do we use RegEx? I already talked about this before. It's just matching or searching on strings, or like extracting a part of a string, doing string replacement, doing validation, stuff like that. RegEx is actually really old. I think it's like developed in the 70s, like with Unix, but actually as a concept, it was started like in the 1950s. It was first added to Perl and Tcl, but it's since then been added to basically every single language because it's just so gosh darn useful, and also in Unix shell scripts too. So any regular language can be converted into a finite state automata. So you can sort of think of RegEx in that way. And FSA is like where you have you're in one state and you transition to another state based on the input. And so you can think of the text that you're searching through as the input, and see where you progress until you get to the end, and in which case then you would match your string. It doesn't really mean that. So how does a RegEx engine work? It doesn't actually do that, which I'm surprised by. But it actually does a depth first search and does this backtracking, where if the string starts failing the pattern, then it kind of rewinds and tries another part of the pattern, and so on. A lot of languages don't, but some languages still use the RegEx pattern format, which is like / pattern / modifier. There are 3 modifiers: case and sensitivity, global, or multi-line. You would use this like in sed, but also in JavaScript when you're making a RegEx pattern. In most languages, we don't even have this format. You can just give the search pattern as a string. Okay, so I talked about metacharacters a little bit. So I think this should be familiar to most people. Like star is 0 or more, so it's like an optional thing. Plus means at least 1, and then question mark is either 0 or 1. And so that can apply to a single character, or it can apply to a group, or to a character class. Then there's lesser used occurrence metacharacters, which are in the curly braces. You can put a number of occurrences that you want, or in between a range of occurrences, like between you want your password to be between 8 and 16 characters, for example, or greater than or less than. There are a bunch of other special characters that just makes it easier as shorthand. So like the \W is commonly used to denote alphanumerics and underscore, and people always forget the underscore. And then any kind of number 0 through 9 is just a \D, and then the capital versions are always the negations, which is kind of clever. There's a \S for white space, which is very handy. So it'll do a space or a new line or tab or stuff like that. And you can also, you know, manually specify the ASCII code. There are some characters that you have to escape if you want to use it as a regular character that you're searching on, right? And these are just, you know, special characters that mean something else. So just escape everything with a backslash before it. You know, especially things like, you know, star plus question mark, things like that. So there's a beginning of line, beginning of message, end of line, end of message. These are depending on how you do your search. Usually it's like the entire string. So like caret means the beginning of the, and dollar is the end of it. So you'll often see a lot of regexes where there's a caret at the very beginning and a dollar at the very end, which means the whole string has to match this pattern. And then, oh, another clever one is \B for word boundary. So it doesn't actually match a character in the string. It sort of matches the boundary, which is clever. Here's some examples. You got, you know, a floating point number. So I'm going to match on at least one digit, possibly have a decimal after that, and then possibly, you know, 0 or more digits after that. So, you know, that's a very simple example of regex. You can get more complicated, like with a phone number. So for the parentheses, because it means capturing groups in regex, you got to put a backslash in front of it. And then over here, I'm using the curly braces to denote how many digits I want. 3 digits, 4 digits for a US phone number. Oops. Or if I want a password to be alphanumeric, but I need it to be between 8 and 16 characters, then you can specify it that way with the curly braces. A character class is anything that's inside square brackets represents one character. It's just like anything within that range could match that one character. So, you know, if you want to do alphanumeric without the underscore, you can do A through Z, 0 through 9. It is case sensitive, so you have to specify A through Z twice. And the tricky thing is, so hyphens are special. So if you want to match on a hyphen, you have to put it at the very end. And carets are special. So if you want it to, if you want to match on a caret, you got to put it not as the first character in the character class, because if you have a caret character in the beginning, it means negation. So it means not any of these. Okay, I just talked about hyphens. There's also a way to do subtraction and unions, and I've never seen this, and not all regex engines support that. Let's see, oh, and also it's kind of tricky, but /B outside of a character class means a word boundary, but inside a character class, it means a backspace. Oh, and just like caret, right? So caret is used for negation inside a character class, but outside of it, it means beginning of message. We also use parentheses in regex, basically just to group things and also for capturing. And when I say capturing, I mean, you know, when you match a pattern, a string to a pattern, you might want to extract just parts of that. And so that's what the capturing groups are. So anytime you see parentheses, it means it's going to be captured into a group. A lot of times you'll see a regex with parentheses, not because it needs to be captured, but just because we want to, you know, sort of group things together. So like, for example, you know, we've all seen the MAC address, like, you know, the machine MAC address, which is like 6 sets of 2-character hex digits, right? And so here's like and then separated by colons or dashes. And so here's like a regex that would match that. And so we put parentheses here because we're saying, oh, I want to have 2 hex digits followed by a colon or a hyphen, and do that 5 times. So that's why it's in a parenthesis. But the more useful one clever thing you can do with capturing groups is you can actually, in the same string, refer to something that was already matched. So like if you're trying to match XML tags, for example, or HTML tags, you know, you always have a beginning and an end tag with a slash. Well, if you match on one tag and we don't know what the tag is, you can also match on the backslash tag later on in the same string. So that's a clever usage of capturing groups. And if you happen to have capturing groups, but you also use you want to group things, for things like alternation, like with the OR pipe, but you don't actually want to capture it, you can put a question mark colon in, at the beginning of the group, which means that you're not going to capture it. I know it's kind of clunky syntax, but you get used to it. I mentioned the pipe operator, which is just alternation, and you can use parentheses to group around that. Note that regex by default is greedy. So like if you have a search string like this, Java pipe JavaScript, and if you pass it JavaScript, it will just match on Java because it's greedy. It's like, oh, I'm already done, so it's not just going to stop there with the first match. So if you worry about things like that, you can always transpose the order or do something else fancy. Okay, so one not often used feature of regex is look ahead and look behind. So with look ahead, it means starting at this point in the string, I want to make sure that what follows looks like a certain pattern, but I don't actually want to process that as part of my final pattern. So I'll give you an example over here. I want to verify that a password has at least one alpha character and at least one numeric, and you've seen websites that have that constraint for passwords. Well, we can have a look ahead here to make sure that it can have any alphanumeric, but it has to have at least one alpha, and then look ahead as well that there's at least one digit, a numeric digit, and then the final group over here actually captures the whole password. Okay. And there's also a negative look ahead, which is just the opposite, where you want to make sure that it's not capturing, and that's with the question mark exclamation point. And then there's look behind. So like at a certain point in the string, you want to make sure that what precedes you matches a certain pattern without actually capturing that. I haven't really seen any good examples of this, but it does exist if you want to use it. And I give an example over here, like matching to make sure that the dollar amount follows something that says it's in US dollars. Okay, so most of us are familiar with the star and the plus and the question mark. That's the default behavior for regex, but regex can be greedy, reluctant, or possessive. And I have an example here where I have a long string foo bar, foo bar, foo bar, foo bar, foo. By default, it's greedy and it will just keep. So if I do f dot plus bar, the regex engine will basically try to swallow everything after the f and then include the bar at the end. But if you have a question mark after the modifier, it'll grab as little as possible. So we call this reluctant or lazy. So in this case, it'll just grab foo bar, the first bar, and then it'll stop. And then there's something called possessive, which I've never seen really used in real life, but it'll just grab as much as it can, because dot plus plus means like basically grab all the characters and then it won't backtrack when it fails. It'll just fail. And then there's some examples I have in Java and in Groovy, but in Scala. I'll just skip that. And I'll just go through some canonical examples. So, for example, you might have an email address, and I just realized recently that there are more characters that you can put in the local part of an email address than what I have specified here. But just as an example, you want something that has an @ sign, a bunch of alphanumerics, and maybe a dot or a dash inside the local part, and then some kind of domain after that. Got a phone number. Now, US phone numbers have an area code that has to start with a 2. or more, and also a prefix that has 2 or more. And so this is a more constrained version of the US telephone number pattern. We just talked about MAC address and stuff like that. Here's a really long one, which is a password that matches, which is between 8 and 20 characters. Make sure that you have mixed case, has a numeric, and has some special character. And so we have a whole bunch of look-aheads here before we actually capture the password. And here's a funny one. If you want to look through a list of a user dict or something like that, and you want to look up all palindromes, you can just match on single characters, and then using the backward reference, you can refer back to the groups that were already captured.
That looks great. Want to jump to the conclusion, Paul?
Oh, okay. There's some gotchas. It's slow and hard to understand. There's something called catastrophic backtracking, which will actually sometimes break an engine. Like if you try to process that, oops. There's a great website called RegEx 101, which allows you to test out your regexes. I use it all the time. And that's it. And I'll put these slides up. I'll share these slides with you guys on the meetup.
Awesome. Thank you, Paul. Super nice to have all those examples. All right. We can take one question.
Just a comment, this was very useful.
Oh, goody. I'm glad you found it useful.
Yeah, I would say that a lot of us are regex aficionados. I'm glad you mentioned the website. There's also another website, I think it's called regexer.com. They're pretty compatible. The one thing I don't think you mentioned is that there are various regex languages, and I think Perl compatible is probably my favorite. It's the most powerful, I think. But JavaScript and Bash, they do different things.
Yeah, I find that annoying that every language implements regex a little differently. So, your regex stream might work in one language and not another.